Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 2.6b, 2012 edition, Solving Inequalities lesson. Pause while you write Section 2.6b, 2012, Solving Inequalities lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is use the addition, subtraction, multiplication, and division properties of inequality to solve inequalities. Now let's take a minute to write down the key ideas for this lesson. I know there's a lot of writing to do, but it's really important that you have all of this in your notes, so be sure you write everything exactly as it appears, the words and the algebra. If you add the same number to each side of an inequality, the inequality remains true. And if you subtract the same number from each side of an inequality, the inequality remains true. So that's exactly like what we do with equalities. So these properties are true for less than, greater than, less than, and equal to, or greater than, or equal to. This study tip over to the left is important also, where you can solve inequalities in much the same way as you solve equations. You use inverse operations to get the variable by itself. Now let's look at multiplication and division properties of inequality, case 1. Be sure you highlight where it says case 1 because it's different than case 2. If you multiply or divide each side of an inequality by the same positive number, be sure you highlight that, the inequality remains true. So if A is less than B, then A times C is less than B times C for a positive number, C. And be sure you highlight all of that with your algebra. And then let's look at multiplication and division properties for an inequality for case 2. If you multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed for the inequality to remain true. So that's the important part to remember. Everything stays the same unless you're multiplying or dividing by a negative number, and then you have to flip your inequality sign around. So be sure you copy this algebra part correctly into your notes. Now let's look at example 1, solving inequalities using addition or subtraction. Letter A asks us to solve x minus 5 less than negative 3 and to graph the solution. First, we write the inequality, then we undo the subtraction by adding 5 to each side. When we do this, the x is by itself on the left, and negative 3 plus 5 gives us a positive 2 on the right. So that gives us x less than positive 2. When we graph that, since it's less than, we have a circle at the 2 on the number line, and then our line goes all the way to the left on the number line. We can check our work by plugging in any number to the left for x and seeing if it works in our inequality, or any number on the right to see if it's not a solution, to see if our inequality does not work. And now let's look at letter B. Solve negative 3.5 less than or equal to 4.8 plus x. First we write the inequality, then we undo the addition by subtracting 4.8 from each side. When we subtract it on the right, the 4.8 goes away, leaving us with just an x, and when we subtract it on the left, it ends up being negative 8.3. So this can be read as negative 8.3 less than or equal to x, or x greater than or equal to negative 8.3. You can flip that around. So that is our solution. When we graph this, we draw a number line, and it has a 0 and negative 8.3, and we fill in the circle because it's less than or equal to. So that shows that the negative 8.3 is also a solution. And then we color in the area all the way to the right because x is greater than or equal to the negative 8.3. Now we're going to do example 2, solving inequalities using multiplication or division. Example 2a is to solve x divided by 10 less than negative 2 and to graph the solution. So our first job is to write the inequality, and then we undo the division by multiplying each side by 10. So our 10s go away on the left, leaving us with x, and on the right we multiply 10 times negative 2, which gives us negative 20. So the solution is x less than or equal to negative 20. And we need to remember that we can always check our solution by using an x in our solution set to see if it works. So if we plugged in an x like negative 30, we would see that that works. So negative 30 is less than or equal to negative 20, and 0 is not less than or equal to negative 20. So our solution works. Letter B is solve 2.5x greater than 11.25 and to graph the solution. So we write the inequality and we undo the multiplication by dividing each side by 2.5. So our 2.5's on the left go away, and when we divide, we have x greater than 4.5. So the solution is x is greater than 4.5. So we graph our solution, and it's right there. Example 3, we're still solving inequalities using multiplication or division, but now we have to be really careful because we're dividing or multiplying using a negative number. So letter A says solve y divided by negative 4 greater than 6 and graph the solution. So we write the inequality and we undo the division by multiplying each side by negative 4, and we reverse the inequality symbol because 4 is negative. So when we do that, our negative 4's on the left go away, and we multiply negative 4 by 6 and we get negative 24. So our solution is y is less than negative 24. So when we graph that, we have a circle not filled in, and our graph goes to the left. Letter B says solve negative 21 greater than or equal to negative 1.4y. So of course we write the inequality and we divide each side by negative 1.4 in order to undo the multiplication, and we reverse the inequality symbol because negative 1.4 is negative. So when we do that, our negative 1.4's on the right go away, leaving us with just y, and negative 21 divided by 1.4 is 15. So the solution is y is greater than 15. So I'm going to draw a quick number line because the book failed to graph that for us. So if 0 is down here, and I'll make it a really short number line, 15 is here, we fill in our circle, and then graph everything to the right, showing that everything to the right and 15 are included in our solution set. Now we're ready for example 4, solving a two-step inequality. Solve negative 3x plus 2 greater than 11. So first we write the inequality, then we undo the addition by subtracting 2 from each side. So we subtract 2 from the left, and our 2 goes away, and then we subtract 2 from the right, and we have positive 9, and so that leaves us with negative 3x greater than 9. So then we need to undo the multiplication, and we do that by dividing each side by negative 3. This is where we have to remember to reverse the inequality sign. So that flips around the other direction. So our negative 3's go away, leaving us with just x, and we have 9 divided by negative 3, which gives us a negative 3. So it's x less than negative 3 when we simplify. So that's our solution. Example 5 is a real-life application. A contestant in a weight loss competition wants to lose at least 30 pounds in 4 months. Go ahead and circle that. Write and solve an inequality to find the average number of pounds the contestant must lose in each of the last 2 months to meet the goal. We use the progress report to write an expression for the number of pounds lost. So here's an equation. 9 plus 5, that's what they lost in the first 2 months, plus x, that's what they need to lose in the last 2 months, equals 14 plus 2x. So we combine the terms there. Because the contestant wants to lose at least 30 pounds, we use the symbol greater than or equal to, because they would be happy if they lost 40 pounds also. So we write the inequality, and then we subtract 14 from both sides so that we make that 14 go away. So it goes away from that side, and then 30 minus 14 is positive 16. And then we divide by 2 to make that 2 go away from the x. So 2 divided by 2 is 1, so it goes away on the left, and 16 divided by 2 is 8. So x is greater than or equal to 8. So the contestant must lose an average of at least 8 pounds in each of the last 2 months to meet the goal. Your assignment for this lesson is to complete the following practice problems. Be sure to graph a solution for every single problem. That means you need to draw a number line for each problem. Show your work and be prepared to share during our next class. Remember, to earn credit for viewing this flipped lesson, you must complete your exit slip. Come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for your teacher, and, of course, always have a good attitude. See you tomorrow.